a student of B4 batch, and my roll number is 62. So, for this role play activity in DSD, the topic that I choose to explain is full adder in Verilog. So, let's start with it. Full adder using Verilog. We all know what full adder is. Full adder is a combinational circuit which adds three binary inputs, which we have taken as A, B, and C in our case, and gives the output as sum and carry. XOR gates are employed for such sum operation and OR gates for carry calculation. So this is the truth table for full adder. As I've previously mentioned, the inputs taken are A, B, and C. The outputs are carry and sum. So now based on these outputs, we can make a K-map, and hence we will get the equations which we will use in the code. This is the circuit diagram, and the sum operation employs XOR gates, and the carry is calculated by and OR gates. Let us talk about Verilog. Verilog, just like VHDL, is a hardware description language. Both are designed to specify and describe digital circuits and systems. Now, if we talk about the syntax of Verilog and VHDL, the syntax of Verilog is a bit simpler, and one more important key characteristic is it is similar to C programming, the syntax of C programming. Now let's go to Xilinx and try to work out the code. We'll give the name of project as full ladder. Now there are certain rules that we need to follow while naming a project. We cannot start the name with a number, and the only special character allowed is an underscore. Next, no changes required here. No new source. When we used to use VHDL module, then we used to select this. But since now we're using Verilog module, we have to choose this. And same rules are applicable for writing the name. Full ladder 00. Now let us give it inputs and outputs. Inputs are A, B, and C, and the outputs are sum and carry. Now, since sum and carry are outputs, we need to change its direction accordingly. Next. Now that we're done with that, this is where we write the code. An important keyword is keyword assign in Verilog. We assign sum as A XOR B XOR C, and we assign carry as A and B, or B and C, or C and C. And semicolon is very important here. As I said, it is similar to C programming language. As in our regular English, we put a full stop when we are after any sentence. We have to put a semicolon here, and then we save the syntax, save this code, and we check syntax. It is correct. If had we not put in the semicolon, then the syntax would have been wrong. Now let us see the RTL schematic of it. This is the RTL schematic. RTL stands for Register Transfer Level, and a schematic at RTL level is often referred to as RTL schematic. It is basically like a blueprint that shows how information moves from storage units and operation is done in the info. These are our inputs and these are our outputs. Now let us simulate it behaviorally. New source. We'll choose test bench waveform since we need to see that. A test bench waveform represents the graphical description of signal changes over time during a simulation. It visualizes how the inputs, that is A, B, and C in our case, and output, sum, and carry of full adder change in response to different scenarios. In simple terms, it is a graph that shows how full adder behaves during testing. Let's name it full ladder 0001 underscore PV. PV stands for test bench. We'll choose this as combinational and finish it. Now to explain this, we'll have to go back to the table. If you look at this, there's a pattern. First, in the A column, the first four inputs are 0 and then the next four are 1. Then we'll keep the first four as 0 and the others as 1. In this, the first two are 0, the other two are high again, then the next two are low again. Then low, next two are high, next two are low, next are high. And in the third column, every immediate step is a new input. 0, 1, 0, 1. Let's save it. And now let's simulate it. Here we have it. Now let's check if this is correct. If we choose this case where the inputs are 0, 1, 1, 0, 1, 1, then the sum is 0 and the carry is 1. The sum is 0 and the carry is 1 in this case, as you can clearly see. So now for Verilog, we just now use Xilinx ISC 8.1. For references, I used chipverify.com to understand Verilog and siliconvlsi.com to develop the code for full adder. Thank you so much for staying with me till the very end. I hope you understand.